Hi, welcome to the calculus portion of our tutoring. Today we're going to be learning about limits of functions, and this is part 1. So let's start our lesson off with an assumption. Assume for the limit x as x approaches a for f of x equals alpha. For the limit x approaches a for g of x equals beta. And know that alpha and beta are both finite values, meaning they are limited. By that I mean they are a countable number less than plus or minus infinity. I'll give you a list of examples. So a finite value can be 1, negative 5, negative 6, 4, 1.5, 2.75. Know that you can also write these as fractions. So 1.5, you can write it as 3 over 2, since they both equal the same. So let's start off with a list of formulas. So our first formula is the limit as x approaches a for k times f of x. Know that k is a constant. So as x approaches a, there is no x in k, so k is left alone. So the limit only affects f of x. And due to our past assumption that we made for the limit as x approaches a, f of x equals alpha. So this portion of the equation turns into alpha, equaling k times alpha, whatever the finite value of alpha would be, and whatever the constant of k would be. Next, we have the limit as x approaches a, f of x plus g of x. Know that you can expand it into two different portions. So limit x as x approaches a for f of x plus the limit as x approaches a for g of x. Due to our past assumptions, the limit of f of x turns into alpha, the limit of g of x turns into beta. So it's alpha plus beta, which gives you our final answer. Over here we have the limit as x approaches a, f of x times g of x. We can do the same thing with our assumptions. So the limit of f of x is alpha, the limit of g of x is beta. So alpha times beta gives you your final answer. In our last formula, we have the limit as x approaches a, f of x over g of x. So the limit of f of x as x approaches a is alpha, and the limit of g of x as x approaches a is beta. So it would be alpha over beta. Know that beta should never be 0, since if in an instance beta is 0, it would be an undefined number, since it would go up to infinity and never come down, or never become a finite value. So let's start some questions right now. So for question 1, we have limit as x approaches 1. Inside we have x plus 1 times x minus 1 times x plus 3. So as limit approaches as x approaches 1, it's kind of like substituting, but it's not the same, since it approaches 1. So yeah, like imagine this is your graph. You have 1 over here. So it's trying to find out the value at 1. So let's say it's 2. But it approaches. So approaches to this value, and while it approaches, it's this portion. But your answer is the same as substituting. So you replace x as 1, and you get 1 plus 1 times 1 minus 1 times 1 plus 3, which is 2 times 0 times 4. Since there's a 0, the final value would be 0. Okay, now let's do a tougher question. So question number 2 says limit as x approaches 1 over 2, you have 2x squared plus 3x minus 2 over 2x squared plus 1. So the smart idea to do for now is factor these into two different components. So you can turn it into, make sure when you're factoring, you never forget this, because if you forget it, it's going to be a completely different function. Not even a function. It would be an equation. So you should always carry the same limit for every calculation. So over here you can factor it out as 2x minus 1 times x plus 2. And you keep 2x squared plus 1. So over here we replace x for 1 over 2. So 2x would be 1, since 2 times 1 over 2 is 1. So you have 1 minus 1, and you have x plus 2, which is 1 plus 2. Over here you have 2x squared, so it's 2 1 squared plus 1. Note that if the denominator would be equal x, then you would say no solution. Like for example, if this somehow equaled 0 in an instance, 2 times 2, for example, this is not the answer, but for example, if it's 0 at the end, then you have no solution, because you only have one way of getting the answer, and when you have a 0 as your denominator, it proves that you have no answers. So you just write no solution, or whatever the preferred way your teacher says. So over here we do have a solution, since the denominator doesn't equal 0. So you have 0 times 3 over 2 plus 1. That's going to be 0 over 3. And since 0 is on the numerator, it equals 0. So yeah, that's how you apply it into functions.